Ladies and gentlemen, thank you for joining us. Today we present solution for parking lot management through a database management system. What is parking lot management database management system? As we all know that parking is a crucial aspect of urban living and DBMS can significantly enhance efficiency and effectiveness. So what are the areas of application? Research indicates that cars remain parked for 95% of their lifetime. Our data model addresses issuing tickets, managing payments, and providing hassle free options like monthly passes. Challenges in storing data. So, we face a lot of challenges while storing the data, which includes identifying customers and vehicles, managing empty parking lots, facilitating payments, and addressing the needs of remote and walk in customers. Why use DBMS for the parking management system? We all know DBMS is essential for concurrency, control, data integrity, transaction management, efficient data retrieval, backup and recovery, and its scalability. So, what is our problem statement? The problem statement goes like this. Our parking lot and ticket management system aims to revolutionize parking by introducing automation and enhancing user interactions. It focuses on efficient parking lot management, user and vehicle information management, payment processing, reservation, and regular pass systems.
So to achieve this particular, to provide a solution for this particular problem statement, we are going to use these entities. So coming to the entities that which we are going to use, we have user, where the respective user details will be stored with their unique email and unique user ID. And also all the payment information is stored in the payments entity, and all the vehicles that are related to the user and the parking lot are stored in the vehicle entity. And also the ticket, where we can get what is the ticket that is issued for that particular vehicle, can be stored in the ticket entity. And coming to the parking lot, this is our main entity where we are providing the solution for. And but this particular parking lot contains the name, capacity, and the location. So going next, we also have these a few more entities as well, like the user vehicle entity, where we are tying up our user details with the vehicle details. And also we have the parking lot reservation. So this particular entity helps in making an advance booking or advance reservation on that particular parking lot for a particular user. And also the regular pass entity, which helps our customers or our users to make a monthly passes or a bi-weekly passes based upon their requirement. And coming to the parking lot vehicle, this particular entity will define which vehicle is staying in which particular parking lot, such that it's very easy to identify the vehicle and the respective relation between the vehicle and the parking lot. So going next, we have these all relations which were maintained between these entities, like the parking lot vehicle, where we can have the one-to-one relationship between a parking lot and a vehicle. There will be many vehicles each and every day coming into the a particular parking lot. So to maintain that, we need to have an one-to-many relationship that is maintained in this particular parking lot vehicle entity. And also we have the payment to ticket relationship, and also the relationship between the user to user vehicle, where one user can have n vehicles. So that particular relationship is also maintained by these entities. So going next, we'll be having all the constraints.
Now, we need to enforce some constraint to our entity. This is to enable us to be able to be straight, to make our database to be efficient. The first constraint we are going to be enforcing is on our user, in which the primary key, which is the user ID, must be unique, not none. We also have ticketed entity. We are going to be also adding a constraint, which is also to the ticket ID, which is going to be unique and not none. Also, we also have payment entity. The payment entity, the primary key is also payment ID, which is also unique, not none. But we are going to be having ticket ID, which is going to serve as a foreign key to the ticket to the payment entity. Then we also have the parking lot entity. The primary key there is the parking lot ID and is also unique and is also not none. Then we also have vehicle entity. The primary key there is the vehicle ID, which is also unique, not none. But we are going to be having the vehicle, the foreign key there. Okay, we are moving to the next, which is the user vehicle. If you can see, we have user and we have user vehicle. The reason we have these two different entities that individual user can have more than one vehicle. It means one person can have 2, 3, or 4 vehicles. Because of that, we have user vehicle entity in which the user ID is going to be a foreign key in the user vehicle entity, and the primary key there is the user vehicle ID. We also have parking lot vehicle entity. Just like user and user vehicle entity, we also have parking lot and parking lot vehicle entity, in which the foreign key there is going to be the ticket ID. Then we also have regular pass entity, in which the primary key is the regular pass ID. Also, we have some foreign key there. The user ID we also have as a foreign key. We also have the last one there is parking lot reservation entity, in which the primary key is the parking lot reservation ID. The foreign key there is the user ID. And we also have parking lot ID to also be another foreign key.
Coming to the ER model, we have 7 different entities. We can see that ticket entry, ticket entity, payment entity, and regular pass entity, user, and all those. And we have 2 relationships here over here. We can see that the parking for ticket, parking lot ticket, and parking lot vehicle. These are the 2 relationships between a parking lot and ticket. And we can even find primary keys in each of them, each of the entity, like payment ID in the payments, and ticket ID in the ticket, and parking lot, a parking lot ID. These are the few primary keys over here. And we can also find this multi attribute over here, like color. It have multiple the cars which are at multiple colors, so we take it as multiple constraints on local and state level. In local level, like in our local level, the funds are too less, so the development over here is too less, so the implementation in the parking lots are too low. And when coming to the state level, the initiative taken by the government at national parks, etc., over there. So we have much and many more funds over there. So the development over the parking and ticket management is going well. Coming to the next slide, this is our roadmap. Uh, all of our team members working hard on this, like starting from the review of our ER model to reduce redundancy and creating relationships. Like these are done by me, Manikanta, and Vamshi. Going to the third one, creating data dictionaries, like done by the Roman and Kavita. So until the end of this, we have done the verification and validation of DBMS. That's it for now. Thank you.
Stop